Most of us waste a lot of foam board while building an airplane. Let me show you how you can use Blender and Python to minimize wastage of foam board and build model airplanes like a pro. I will split the tutorial in two parts. First, I will show you how to use Blender to trace individual parts of an airplane. Later, I will use a Python script and a 2D packing solver to find a tight packing of parts on a foam board. As I am not an expert in airplane design, I will use a ready-made plan of F22 fighter airplane from RC Foam Fighters. There are numerous other websites offering free airplane plan. As most of these plans are available as a static PDF file, it is difficult to interact with them using a Python script. So, let's begin by tracing the airplane parts in Blender. I will start by importing the reference image. You can scale this image depending on the desired model size. Next, I will add multiple planes to trace each part. Currently, these planes are hiding the reference image. So, I will pull the reference image above the plane and decrease its opacity. I will now switch to edit mode and start using the knife tool for tracing. This step can take a long time depending on the complexity of the design. So do remember to take breaks to avoid eye strain. Once the tracing is complete, I will hide the reference image to check the quality of the final drawing. To separate a part from the underlying plane, I will select the corners of the plane and delete these vertices. I will repeat this process for other parts of the airplane. I am finally ready with my design. You can see that the airplane parts are scattered all over the place. If I start cutting them without proper planning, I will end up wasting a lot of foam board. This brings us to the second part of the tutorial. I want to find a tight packing of the airplane parts on a foam board. As this is a challenging mathematical problem, I will use the open source 2D packing solver named Sparrow. The best part about this solver is that its creators have also built a browser interface. To interact with this solver, I simply need to upload a JSON file describing each shape as an ordered list of vertices. As creating this structured file manually would take too much time, I will utilize the scripting feature in Blender. I have already written a Python script to fetch different parts in Blender and generate a JSON file. Let me run this code and show you what the output file looks like. The file stores all the shape in a format that the solver can understand. Each shape has a unique ID, a demand value specifying how many copies are required, allowed orientations during packing, and a list of vertices in the Cartesian coordinate system. At the end of the file, we specify the strip height, which is the width of the foam board. Using all this information, the Sparrow solver finds a packing that minimizes the total length of the used foam board for a fixed width. Let me go to the browser and upload the JSON file. After invoking the solver, it can take a while to obtain a good solution. In the meantime, you can monitor the quality of the best solution found so far. If you feel that the improvements are becoming small, you can also terminate the solver and get the best solution available at that point. The final packing can be downloaded as a SVG file. This can either be printed and pasted on a foam board or fed to a laser cutting machine to cut out the parts. Both the Python code and the Blender file used in this video can be downloaded using the link available in the description. If you want to take it a step further, you can try calling the Sparrow solver from the Python script and use the solution to redraw the shapes in the Blender project. That's all for now.